Hi, welcome to the online lecture series for the course 8051 microcontroller. In this lecture, we shall discuss decimal adjust accumulator instruction. So this will be the last instruction in arithmetic instructions. The mnemonic is decimal adjust space then accumulator. Okay, so it stands for decimal adjust accumulator after addition. Okay, so basically this instruction is used in BCD arithmetic. Okay, I repeat, this instruction has a meaning only when you are performing BCD arithmetic. That is, when we are performing BCD addition, subtraction, this instruction has a meaning. And this instruction is mostly used after the addition operation of BCD numbers. Okay, what does this instruction do? This instruction is used after addition of BCD numbers to convert the result back in BCD form. Fine. Now, what is a BCD number? It's a binary coded decimal. That is, the numbers are from 0 to 9. Fine. Now, what is the importance of this? See, we have basically in the number system, when we deal with the microcontrollers and processor, all the data will be in hexadecimal. Okay. But as human beings, we uh, understand or interpret decimal form more quickly. Okay. So whenever we add something, the result will be again in the hexadecimal format only. Fine. So to convert uh, again back to the decimal form, so this instruction is used. That is decimal adjust accumulator. Okay. Now how does it do? So in detail I had explained in this class when I was discussing the auxiliary carry flag. Okay. So after the addition of the BCD number, it checks for two conditions. Okay. First, whatever the result you have got, okay, it first checks the lower nibble of the result, that is lower 4 bits of the result. If it is greater than 9, or if there is a carry out from D3 to D4, that is if your auxiliary carry is 1, it adds a correction factor of 6. This is the first case. The second case is it checks for the higher nibble of the result, that is the upper 4 bits. If that upper 4 bits is greater than 9, or if a carry flag is generated, again it adds a correction factor of 6 to convert the back into the BCD form. Okay, so this is done by the processor internally. You need not worry about this, but you should know what is the logic of converting back into the BCD form. So the flags affected are carry, parity, and also auxiliary flag. It is being not written here. You please make an addition of it. The flags affected are carry, parity, and auxiliary carry. Okay. Now, as an example, you see move a comma hash 47h, move b comma hash 25h. So I perform the addition. Okay. So I got 6ch. Okay, so see, by 6c, it's very difficult to interpret for me. So after this, I will apply this decimal adjust accumulator. After this, it will convert back into the BCD form. Okay, so if the result is greater than 8-bit, then it will make carry equal to 1. If the result is not greater than 8-bit, carry will be equal to 0. Okay, so we shall take the same example and execute. Fine. So accumulator contains 47h, register B contains 25h. So after addition, you can see it is 6c. Okay. Now I will apply decimal adjust accumulator. Okay. So after this, you can see the result will be 72. That's what we see. 7 plus 5 is 12. 1 carry. So 6 and 7, it is 72. Okay. Now how does it work? For this example, I will show you. Okay, see, uh, what did we get when we added 47 and 25? We actually got, let us execute again, we'll restart. What we got was 6C. So how did the controller convert that? Let us see that. Okay, so the result what we got was 0 1 1 0 1 0, sorry, 1 1 0 0. So this is 6, this is C. How does the decimal adjust accumulator work? It first checks the lower 4 bits. Okay, so if it is greater than 9, or if there is auxiliary carry generated, it adds 6 to it. So in this case, you can see the lower nibble is greater than 9. So it adds 6 to this. Okay, so let me add 6 to this. 0 1 1 0. So what do I get after this? So if you see, it will be 0 1 1 plus 1 will be 0, again 1 plus 1 will be 0, then 1 1 1, sorry, 1 0. Fine, let me align it. So see here, now what did we do? After the addition, we had got 6ch. Okay, so what does the controller do when you execute decimal adjust accumulator? It first checks for the lower nibble. If the result is greater than 9, if the lower nibble is greater than 9, or if there is an auxiliary carry flag generated, then it adds 6. So in this case, it is greater than 9, so we added 6 here. Fine. So after addition, we got this result 7 2h. Now after addition, if you see, the lower byte of the result is less than 9 or less than or equal to 9, and also the higher bit of the result is also less than or equal to 9. Hence no more correction factor will be added, and we get the result in the decimal form, that is 7 and 2. Fine. So that's about the decimal adjust accumulator. Now one important thing I want to tell you here. What is that? As I told, the decimal adjust accumulator works only on BCD numbers. Hence, the input should always be a valid BCD number. What is the meaning of it? For example, in the same example, if I write here 4C, so you will see that the results will not be correct. Why? Because 4C is not a valid BCD number. That's why the result what you get are not proper, because the input itself are not proper. So the number should be anything of a combination of 0 to 9. Fine. So this is one thing you have to remember. The second thing you have to remember is whenever you give the inputs in BCD addition, it should be in hexadecimal form only. Why is that? For example, if I remove this hexadecimal 47, so for us it is decimal 47 and decimal 25. But as we know, the register stores the data always in hexadecimal. So we have given the numbers in decimal form, that is 47 and 25. But how do the registers store? Now see here, we had given 47. The hexadecimal equivalent of 47 is 2f. Now which is an invalid BCD number. The next is 25. So we gave 25, but it has stored in hexadecimal. That's why whenever you give BCD input, that should be a valid BCD number, and it should be always in hexadecimal form. Only then you can analyze the working of decimal adjust accumulator properly. Fine. So this is one of the most important instructions which is always asked in the examination. Fine. So with this we end the arithmetic instructions of 805. Okay. So let us summarize what we studied. We started with the addition instruction. So we have two addition instructions, add a comma source byte. The contents of the source byte are added with the contents of the accumulator and the result is stored back in the accumulator. We have a variant of this. In this case, the contents of the source byte along with the carry flag are added with the contents of the accumulator and the result is stored back in accumulator. We have only one subtract instruction, that is subtract with borrow. Okay, that's why whenever you perform subtract instruction, we should always clear the carry flag. Then we saw increment instruction, increment byte, decrement byte, and increment dptr. So this adds 1 to the destination. And we also saw whenever we have the maximum value, that is ff, and when we increment, the carry flags are not affected. Fine. And we don't have any decrement dptr. Then we saw multiply ab. So after that, the lower byte of the result will be in a and the higher byte of the product will be in register b. Then we have divide ab, a divided by b. After the division, the quotient is in a and remainder is in b. And decimal adjust accumulator, it is used for BCD arithmetic after addition of BCD numbers. So this ends the arithmetic instructions of 8051 microcontroller. Fine. So what you have to do is you can refer any textbook or my notes and try to practice these instructions on the Kyle software. So the more you practice by writing the simple programs, the more it will be easier when you come across the advanced programs in assembly level language. Okay, thank you.